Let's say I have functions f of x is equal to 2x plus 3 over 3x minus 2. And I have g of x, which is equal to 4x over 3x minus 2. And I want to know what, let's see, I want to know, f plus g of x. I want to know f minus g of x. I want to know f times g of x. And I also want to know f divided by g of x. So let's start with the addition. The addition and subtraction are very straightforward. So let's do that real quick. So we have f plus g of x. That gives us 2x plus 3 over 3x minus 2 plus this other fraction 4x over 3x minus 2. Our fractions have the same bases, so we can just add, and that's going to give us 6x plus 3 over 3x minus 2. So there's our answer. For subtraction, f minus g of x equal 2x plus 3, 3x minus 2. So this is our f function, not plus, minus our g function 4x over 3x minus 2. And this is going to be minus 2x plus 3 over 3x minus 2. So that's that. Now let's multiply them together. So we want f times g of x. So that's going to give us 2x plus 3 over 3x minus 2 times 4x over 3x minus 2. And these have the same basis, so we can just multiply the numerators together, and that gives us 8x squared plus 12x over 3x minus 2. So that's that. And lastly, we have our division. So we have f over g of x. This is going to be equal to 2x plus 3 over 3x minus 2. And this is being divided by 4x over 3x minus 2. And it's useful to know, and you should know, that when we're dividing, instead of dividing, we can multiply by the reciprocal, and it's the same thing as division. So this monstrosity is equal to 2x plus 3, so we have our numerator times the reciprocal of this. So we can do, instead of dividing by this, we can just multiply by the reciprocal, which is almost always much easier, like 99 times out of 100 when you have fractions like these. I mean, I can't really think of any situations off the top of my head where it would be easier to deal with that fraction. But anyways, here we have our equivalent expression. And you can see that these are going to cancel out. But before we do that, we have to take note that if we have a 0 in the denominator, here we can have a 0 in the denominator. So what number would that be? Well, that would be oh, what's it called? 2/3. Yeah, 2/3. So we can't have 2/3. So 2/3 would give us a 0 in a denominator. So x cannot be 2/3. Man, I thought of 2/3, but I just couldn't say it for some reason. And we also can't have 0. Oh, no. No, we can't have 0. That's fine. No, we can't have 0. No, we can't have 0. I'm sorry, I got confused for a second. We also cannot have 0. Because 0 over here, we can see that anything that would make this 0, that means we would have a 0 in the denominator. So even though this is technically the numerator here, in this case it's actually the denominator. It's in the even though this is a fraction, it has anything that makes this 0 will cause this to make this whole thing 0, in which case we have an undefined answer. So it actually can't be 0 and it can't be 2/3. So both of those answers will give us 0. But when these cancel out, we're going to get 2x plus 3 over 4x. So actually it's not necessary to include 0 because we can clearly see that right here. But since this drops out, there's no sign in this equation that 2/3 won't give us a real answer, because if we put 2/3 in here, we'll get a real answer. But this is not the same as this unless we include this, because this dropped out. I mean, if you don't like dealing with that, you might just want to leave it in there. But for me, it's easier just to write x is not equal to 2/3 for the complete answer. So our complete answer is 2x plus 3 over 4x, and x cannot equal 2/3. And remember, unless we conclude this x cannot equal 2/3, this answer is not correct. This is a different function. It's a function that doesn't have this in there. But since this is in there, we need this x cannot equal 2/3. So we've done that, and I have one more quick example, and it's just to show you that we're not always going to be after f of x. Let's say I have a function f of x is equal to 3x plus 4. We'll just do some simple one. I don't really want to take a whole lot of people's time. I just want to show the point. F of x is equal to 2x minus 3. And let's say I want to know f plus g of 2. So there are two ways to go about solving this. Both of it's the same way. So remember, f of g of 2 is going to be the same. So f plus g of 2 is the same as f of 2 plus g of 2. So we can either right away we can just put in 2, find out what that is, and then put in 2 here, find out what that is, and then add those two numbers together. Or we can just combine the functions and then use the final equation to give us the answer. So let's do it both ways. So let's just say we want to do it the plugging in way. So let's just say f of 2 is equal to 3x. We're not dealing with x's anymore. 3 times 2 plus 4, and g, that's a really crappy g. Oops. And then g of 2 is equal to 2 times 2 minus 3. So this is going to be 3 times 2, which is 6. So this is going to be equal to 10. So f of 2 is equal to 10. And this is going to be 2 times 2, which is 4, minus 3, which is 1. So g of 2 is equal to 1. So we can either do it like this, solve them independently, and then say f plus g of 2 is equal to 10 plus 1, which is equal to 11. So this is our correct answer. Or what we can do is do it the way we've been doing it before. So f plus g of 2 is equal to f of 2 plus g of 2. So what we can do is just add f and g, the functions, together. So we can add, where are our functions again? 3x plus 4 is equal to 2x minus 3. So we can do 3x plus 4, 2x minus 3. We can add these together, and this is equal to 5x plus 1. And then we can just put in 2 for this answer. So we can say f plus g of 2 is equal to 5x plus 1 plus 2 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 plus So f of g of x is equal to this. So we can say f plus g of 2 is equal to, bear with me, my pen just broke, so now I'm using the mouse. Oh my gosh, this is so hard. So 5 times 2 is equal to 10, plus 1, this is equal to 11 as well. Wow. Couldn't imagine doing a whole video without a pen. I can't believe it just broke. Oh well.